Today we are pleased to welcome Paul Yetman, Enterprise Solutions Specialist, DATAGRES Technologies Incorporated. Paul, an Enterprise Solutions Specialist, engages directly with prospects and customers, building integrated product solutions and ensuring customer success in every area of DATAGRES product development and use. Paul has come to DATAGRES after many years in the backup and storage space and with a Linux administration background. Welcome, Paul, and thank you for taking the time to join us.
Okay, thank you, and hello everyone. My name is Paul Yetman, and I'm looking forward to giving you a demonstration of using PerfAccel in our own environment here, and hope you find it useful for potentially in your environment. So discussing environment, let's start with the environment in which PerfAccel can begin bringing visibility for the I/O that is moving within your data center. So a server farm environment like this, let's say you have one or more Linux server farms as pictured in the slide. This is all networked with some type of back-end storage. So you may have NAS devices in the back end that are exporting all of the data via NFS to your applications that are running within the Linux server farm. So this is a scenario that we'll be working within today, kind of setting the stage for the demonstration to come. And what we want to start with is what kind of visibility we would have in this type of environment before we even bring PerfAccel in. So ultimately we want to get to looking at some of the information we can see about I/O using standard Linux tools that are generally used for monitoring in an environment like a Linux server farm. So I have a terminal here that is logged into a node. That could be one of the sample nodes in your Linux server farm. And just to show this setup on the machine, it has a few NFS mounts, actually just two. So we have one there and one here. You can see it's the second mount, so both of these are coming from back-end NAS devices. And you can see that this second one here is mounted to a directory called NFS-source. And within that, we can see a MySQL directory. And this is the MySQL data directory for a MySQL server that is running on this system. And I'll be using that as part of an example of, how can we see the I/O that's running for specific applications, such as like a MySQL server. So just starting with top, the other thing we can note on the system is you can see that the system is already quite a bit under load. We see a fairly high load on the system already. We can see around 50% usage of CPU. And we can see that almost all of that is coming from QUMU KVM. So this server is also serving up virtual machines using KVM. Just to show the DF again, we can actually see that on drive SDC, mounted to virtual machines directory is where all the virtual machine information is. So from looking at that, we can see what else is going on the machine. So this can be interesting in terms of how do you know the I/O that's happening for one application like KVM and it hosting several virtual machines versus another application such as a MySQL server. So with top, we can see the KVM process is running. We can see that they're using a high, about half of the CPU utilization of the system. We see a fairly high load. And to begin to bring MySQL into this, I'm going to bring up another window logged into the same host, and I'm going to start running 400,000 MySQL transactions using the sysbench command, just a common I/O tool for creating I/O or benchmarking within Linux. I'm going to run it with 64 threads, so 400,000 MySQL transactions using 64 threads. I'm going to precede it with the time command just to make it simple to see how long this takes to run the 400,000 transactions, and we'll go ahead and start that. So as that's running, we can begin to see the MySQL-D process begin to rise up a little bit here. So we can see that that's beginning to create load on the system. We can see the system idle time drop way down. So we can see the load beginning to go way up compared to the recent past. So we're putting the system under a lot of load, as would be in production. And now we want to begin to understand how can we understand the I/O that's occurring from this. And of course, top itself doesn't tell us much about I/O, really about CPU, memory usage, and overall load, which is an indication of the I/O, but doesn't give us any specifics about the I/O itself. So moving on to the next command, let's look at vmstat1. Vmstat does tell us some specific information about I/O. It has a column here dedicated to the I/O, specifically to the blocks that are coming into the system versus the blocks that are going out of the system, so the reads and the writes. And here we can, just kind of looking at it with my eye, it looks like I'm seeing a lot more writes than reads. So I can see that there's a lot of I/O happening on the system with VMstat. I can see that the workload characteristic seems to be more heavy on the reads just from watching the lines go by. So this begins to give me some information as the I/O happening on the system, blocks coming in, blocks coming out. Again, this is probably VMstat I would expect to only be showing for the local block devices. So this may not be indicative of the data coming from the NFS mount. For sure, IOStat is just showing local block devices. So we see just the local devices mounted here, SDA, B, C, D, E, and so on. A couple RAID devices down here at the bottom. We can see transactions per second in a column here. We can see throughputs for reads and writes. We can see total data size that's been read and written. So IOStat is starting to give us some good information here as far as the I/O in the system. Again, it's just for the local drives. Doesn't take into account any remotely mounted storage. We can begin to see where the I/O is happening. We can see that there's really nothing happening on B. We can see that there is some on A. There's quite a bit on C. If you remember, that's where the virtual machines mount was coming from, was the dev SDC drive. So we see quite a bit of I/O activity on C and quite a bit in a rated partition down here as well. So we can see where which drives the I/O is happening on. We can see numbers as far as throughput. But again, it doesn't tell us about any remotely mounted storage. If we look at NFS IOStat, now we can see at least any NFS mounted directories. So we see the two directories here. Here's one at the top, and here's the second one in which the MySQL server is receiving data. And in this case, we can see total number of operations per second, and for both reads and writes, we can see operations per second, throughput, retransmissions. So this kind of information is good. We can see I/O at the device level, and with IOTop, we can ultimately see also I/O at the individual process level. So here we can see total disk reads and writes for the system. Let's see what this is showing as far as reads and writes. I see, again, this seems to show a much more heavy write characteristic than a read characteristic. I see the megabytes per second fairly frequently over here on the writes more than on the reads. So here with the top, we see the top processes using the most, causing the most I/O. We can see here that at least these particular processes coming from the MySQL server are really only doing reads, at least these top ones. So we can see from the MySQL server mostly doing reading, even though on the system it looks like there's more heavy writes. So this is the type of information we can see with Linux tools available for common monitoring tools available on Linux. And this is good information. Just to summarize, we can see blocks coming in and out of the system. We can see the throughput per block device, and we can see throughput per process. So this is good information, but still having only this information about blocks and throughput, either at the device level or at the process level, is still limited. We still don't know total number of I/O requests from client nodes or applications. We don't know total number of I/O requests fulfilled by the backend storage. Additional information is missing. We don't know anything about latency or queue length while fulfilling I/O requests. We don't know about the I/O that's occurring for a specific application. So with Linux monitoring tools, we can see at the device level, at the process level, but we can't, even with IOTop, where we can see individual MySQL processes running, we don't have an idea of what is the application, what kind of I/O is the application causing overall in both reads and writes. And lastly, we don't have any file level detail with the Linux tools. We don't have any information about what exact files are being read and written to. And how much they're being, to what extent are they being read and written to? How often are the files being opened and closed? This type of information is missing. So at this point, let's bring in PerfAccel, and let's discuss, first of all, how it's deployed, how it's set up, and then let's begin to see what kind of information we can see with PerfAccel on the system. PerfAccel deployment, the first thing is to get a lightweight client on all of the nodes that are installed within the farm. Installing the client allows you to set up certain directories to be watched and also certain processes to be watched. So we can begin collecting data about the I/O that's happening on the system according to what you're most interested in seeing. And then the one other piece is to add a dedicated system that acts as the management node And the management node serves two purposes. It's a centralized repository of all the data metrics from the node. So it collects all the I/O metrics from each of the nodes where the client is running to centralize where the data is kept. And then it also offers a user interface that's available. It's a web interface that's available from your browser that allows you to see the metrics from one pane of glass. So one dashboard allows you to see aggregated metrics all the way down to individual node metrics. Once PerfAccel is installed or on one of your nodes, first thing to do is set up an area on local storage that can be used as a target disk. That target disk can ultimately also be used for caching. You don't necessarily have to use caching. The target disk, at the very minimum, is going to record the analytics of all the I/O that's happening within the directories and the processes that are being watched. So we first need some type of local storage that is set up as a target disk for recording the metrics that are being monitored and saved. And then secondly, we want to set up all the areas we want to watch. So we're going to set up storage mounts, any directories or subdirectories that we want to watch the I/O that's occurring within those directories. And we set those up as what's called PerfAccel sources. So the word source meaning it's the source of data. So each one of these directories or mounts is some of the back-end storage, or it could also be local storage on the system as well. Just to show what is already set up on the system, going back to the target disk or cache drive, the DGPCTL-cache list is going to list all cache devices that I have set up on the system. We can see that I just have one area that's set up. It's on dev SDF1. I've allocated only 60 gigs to it in this case. And just to see what SDF is, let's run the lsscsi command. And we can see that the SDF device is an Intel solid-state drive. So this would be a typical way to set it up, have some type of high-performing disk on the system that is set up, especially if you're going to actually be performing the caching. Have a high-performance disk set up as a cache area. Next, I already have a source set up. So if I change the command to DGPCTL source list, you can see that I have one source device that's set up to watch the NFS source /MySQL directory. So again, this is the data directory in which the MySQL server is running. I just have this one directory set up to watch. I could have as many others set up to watch as I want. I could also set up for instance, the virtual machines directory where all the virtual machines are stored for the KVM server. And I could go further down if I want. If I want to just see the I/O that's happening for specifically the CentOS 65 machine, I could set that up as a source. So I could set up any directory on the system that I want as a source to watch, as long as it's not the root partition. Any mounted file space can be watched with PerfAccel, and I can set up as many of those directories to watch as I want to set up. And lastly, there's a context jobs that can be optionally set up. This is for tracing specific processes or process groups or even session IDs. For instance, I may want to watch a process group that's around a specific application. So by setting up context jobs, I can see not only specific processes that are running, but I can also watch process groups, which means I have the ability to monitor I/O for specific applications such as MySQL Server or KVM Server. So coming back to my terminal here, you can see this by again changing the command to be -ctx for context. I can see that I already have a context job set up, and it's around the process group 12453. So this process group is the process group in which all the MySQL processes are running. So by watching that process group, I'm able to watch the I/O that's occurring just for the MySQL server. So with PerfAccel deployed on application node like this, let's start at the CLI level and see what kind of visibility we can see now. What can we determine about the I/O now that we weren't able to see previously with standard Linux monitoring tools? So first of all, we start to see detailed analytics about all the directories that are being monitored. So to show an example of that, if I use the DGPCTL command again, and I'm going to use the cache device because that's where all the analytics are being stored, I'm going to ask it to show me IOPS. So IOPS gives me lots of information. Just to show, first of all, this is showing just for the directory that's being monitored, the MySQL data directory. We see two lines. Let me quickly explain that. So we see a cache line, and we see a source line. The source line is the source of the data, meaning the backend storage. So this is all the metrics concerning the NFS mount that is coming from the NAS device. The top line is the cache device. This is the local target drive where all of the analytics is being stored, and if I'm actually performing caching, where the caching is occurring. So when caching is occurring, I have all the metrics for my local caching drive as well. So that's why you see two different lines here for the same source directory. And within that, we see a lot of information. We can see total number of read operations and total number of write operations from both the backend storage as well as any data that's being cached. So this is very useful, right? Already we have a lot more information than we had with the Linux monitoring tools. There we could kind of look at things and try to understand the workload characteristics as far as how much is being read and written. But here we have exact number of operations happening within the directory from the time that that directory is being monitored with PerfAccel. We can also see total size of data that's been written and read within that directory. So in this case, it's very obvious from both these numbers that the workload characterization within this specific directory is very read-heavy and very light on the writes. So we can see there's a very read-heavy workload characterization. And also, I just want to point out again that we're able to see this at the directory level, not just the device or process level. So with the Linux monitoring tools, we could really see things only at the device level or at the process level. Here I'm able to pick any directory I want within the system and find out what I/O is happening just within that directory. So again, this is going much beyond what we could see with just the Linux tools. In addition, I can see the throughput. Linux tools showed us for a lot of throughput numbers, but again, not for specific directories. And PerfAccel is also throwing in numbers for latency and queue length. So I can see average latency for data I/O that's occurring just within this directory, as well as the average queue length, how long or how many I/O requests are stacking up on average. So we see quite a bit of information already here with PerfAccel installed on the node. We can see it within the directory level, down to the directory level. And the next thing we can point out is that PerfAccel can also monitor at the process level as well, and most importantly at the process group level. So not only can we see all this information for the directory, but if I change to look at the context job that was set up instead of just the source directory, I can see the same information but for a process group. So by monitoring the process group, I can see the same information, but I'm seeing it for the process group instead of for a specific directory. So this is very useful, being able to see the I/O that's occurring for specific applications running on your server, and especially if that application is working in more than one directory. Allows you to see it across whatever directories it's working within. Next is I can see analytics at the file level, meaning I not only know statistics such as total number of operations, total data size, throughput, I can see the actual files that are being read and written with this directory or with this process group. So if I back it to my cache command, I just change IOPS to file, and I'm going to add an I/O here. And let me also pipe that to less so we can see the headers. I can now see all the files that are actually being read and written within this directory. So again, they're all, of course, MySQL related because it's the MySQL data directory. We can see that they're all database related files. I can scroll on down and see the full list of all files that have been read and written within this directory as monitored by PerfAccel. I can also see total number of read hits and read misses. This is considering caching. So when caching is being used, all the read hits means that the data that was requested was able to be fulfilled from the cache. A read miss means that the read had to come from the backend storage instead of from cache. So I can see total number of read hits, the same thing for write hits, read misses, write misses. And by summing up all read hits and read misses, I know the total number of reads for any file that is being accessed. So whenever you're interested in knowing total number of reads and writes, that information is available to you. And I can also quickly see what files are being accessed the most. So I can see that the IB Data 1, the shared file space for InnoDB database, is being much more accessed than any other file within the MySQL directory. So I can see that the second most important one is the IB log file 1, or second most accessed one. All of this is available for the full list of files that is being read and written to by within the directory. Oh, as far as opens and closes as well, we can also see that data as metadata. So if I change the IO flag to a meta flag, now we can also see total numbers of open and closes, and also total number of stats on any of the files being accessed. And again, it could be of really important interest to a storage admin to be able to have this information. Which file is being opened and closed and the most, and does it make sense, or is it being excessively opened and closed? So we have a number of customers who are really interested in this information to make sure that there's not inefficiencies happening within the environment. If some file is being, or some set of files is being excessively open and closed, that could be an indication that of some type of inefficiency in scripting or a particular application that's running, and that's something that you want to have visibility into and be able to see and understand and possibly diagnose. So just to recap here, we have visibility into the directory level, into the process and process group level, and file level, and eventually to discuss caching. PerfAccel can also cache any of this data within the target directory in order to accelerate application performance. So when you do have a cache device that's a high performance disk that's going to outperform your back-end storage performance, caching all the files that are being most frequently read and written is going to quickly accelerate the performance of your application that's running on that system. So to look at that, let's go back to the window where I started the 400,000 MySQL transactions. We can see that has since completed. We can see that it took 7 minutes and 11 seconds. This is with PerfAccel caching not enabled. So this is just a Linux system with a back-end NAS device amount of time of base time. So in order to show how much the caching can help with an application such as MySQL, I'm going to now turn the PerfAccel caching on. So I have a little script here that I'm going to run. That's going to start the PerfAccel source. So it shows now that my MySQL source is now online. That started the caching. And now what I'm going to do is I'm going to rerun the same command that was run before, run another 400,000 MySQL transactions, now with PerfAccel caching on, so that we can see what type of difference or acceleration we're getting with the cache device enabled. And as a final point in this slide, I just want to again point out that PerfAccel can run in both modes. It can run with caching, or it can run with only showing metrics without actually caching the data. Although even when only showing metrics, PerfAccel is able to show what caching would be doing if PerfAccel was actually performing the caching. So it kind of becomes a virtual cache at that point. And that ties in with what was explaining earlier, where PerfAccel is able to, even with just metrics, is able to determine your workload characteristics and be able to help you with things like sizing your cache device. So let's say you start with running in just a metric mode only, an analytical mode only. PerfAccel will still show what the caching was doing if you were using caching, so that you have a full understanding of your workload characteristics, and you have an idea of how much data would actually be cached within that directory or for that application. And so using that information helps you with being able to buy the right amount of caching space for your system. So there's a lot of detail that's available at the CLI. The couple commands I've shown you is just the beginning. It's just scratching the surface. There's much more I/O detail and visibility that's available with PerfAccel. So very last thing, I just want to get back to the rerun of the I/O test. If I bring up the terminal in which I started the 400,000 MySQL transactions, we can see that previously what took 7 minutes and 11 seconds to complete without caching enabled, we can now see is taking 1 minute and 12 seconds to complete when PerfAccel caching is enabled. So, and this is even with, well, actually, I take that back. I was going to say without the throughput on the cache device being considerably higher, but actually it is. And I didn't point this out earlier. I would like to have shown this, that if you compare the cache to the source device, we can see that we are seeing actually quite a bit more throughput on the cache device on the Intel solid state drive compared to what the backend storage is providing for both reads and writes. And that's exactly what you would want in a cache device. We can also see that were benefiting from the low latency of a solid-state device. So when you are going to want to do caching of hot files, this is exactly what you would want to see in terms of having a cache device that well outperforms your backend storage. And when you have that, you can see the type of application acceleration you can get, where running 400,000 MySQL transactions went from 7 minutes down to 1 minute. So that concludes my presentation and my demonstration. I want to thank you all for giving me the chance to show you the visibility that we can see with PerfAccel. Thank you all.